The last section we're going to look at has to deal with the composition of inverse functions. And there's really two skills we want to see. The first is, when do compositions cancel each other out so you're left with an identity setup? Sort of what you did back in Chapter 1. The other setup would be, how would you solve when you're combining two different types of trig functions together? So that's really our goal for this. So the first thing I want to look at is an example where something cancels out. And here's what I'm getting at. If I were to have the sine of sine inverse of 0.287, that ends up being 0.287. The sine and the sine inverse piece cancel out. If I go sine inverse of sine of 56.7859, I can see that the sine inverse and the sine cancel out. So there isn't a pattern specifically with the order of sine versus sine inverse, one that's inside the function, one that's not. However, I might run into a situation where I can't solve something, such as the sine of the sine inverse of 24. There I'm going to get a domain error. So I want to know what situation is going to emerge where I can simply cancel out the trig function and its inverse, or when do I've got to work out the problem more? So what we're going to look at today, as I said, is the idea of simplifying trig functions. And I want to know, when can I simplify down to x? When does the trig function and its inverse pretty much cancel each other out? And the way we know that's going to happen is if my trig function falls within the domain or the range of the trig function that I'm looking at. So, what I'm saying by that is, if I go back to arcsine, or the sine inverse, we had this little drawing here, and we said that the sine inverse, or the arcsine, was defined in the first and the fourth quadrant. And we said that the domain would be negative pi over 2 to pi over 2, and the range would be negative 1 to 1. That's how I limited my original trig function. So that means the sine inverse would have the domain of negative 1 to 1 and the range of negative pi over 2 to pi over 2. If I did the same thought process with our cosine or cosine inverse, we said we've got to limit our original trig function to be the first and the second quadrant. So my domain for my original function ended up being 0 to pi, and my range ended up being negative 1 to 1. Or if I was dealing with cosine inverse, the domain became negative 1 to 1, and the range was 0 to pi. And then finally, the last one was the tangent inverse, or arctan. And that one had a very similar setup to sine, where it was defined in the first and the fourth quadrant. The only thing that was different is we had asymptotes at pi over 2 and negative pi over 2. So I had parentheses at that point around the negative pi over 2 and pi over 2. And then I went from negative infinity to infinity for the original tangent function. And then if I had the inverse, the domain became negative infinity to infinity, and the range was negative pi over 2 to pi over 2. So I've got to use those restrictions, and if my given problem falls within one of these restriction ranges, I can say, yes, the sine and the sine inverse, or the tangent and the tangent inverse, are going to cancel each other out. So the first one, sine and sine inverse of negative 0.5. Does negative 0.5 fall within the domain or the range of one of those trig functions? And since I'm looking here at the sine inverse, I'm looking at the result of a sine function. So I look up here, and I've got my two options as negative pi over 2 to pi over 2 or negative 1 to 1. And does negative 0.5 fall in between that measurement? And the answer is yes. From negative 1 to 1, negative 0.5 appears in between there. So I can say sine and sine inverse are going to cancel out, and I'm going to end up with negative 0.5. And the reason is that negative 0.5 is in the domain of sine inverse. If this were to have been, say, 2.8, then it would not work because 2.8 does not fall in the domain of sine inverse. The second one we look at, tangent inverse of the tangent of 2. Let's look at this from two perspectives. The first would be, let's say this is the tangent inverse of the tangent of 2 degrees. If I look at it from the degree perspective, tangent of 2 degrees, 2 degrees does fall between negative pi over 2 and pi over 2. Remember, negative pi over 2 and pi over 2 are negative 90 and 90 degrees respectively. So 2 does fall in between negative 90 and positive 90. So if this is 2 degrees, yes, tangent and tan inverse are going to cancel out. And I can confirm that on my graphing calculator. That if I pull my calculator out and I go to mode and I make sure I'm in degree mode for this, and I do tangent inverse of tangent of 2, I see I do get 2. But now the question is, what if I'm in radian mode? And I do the exact same thing again. You're going to see that the angle measurement does not cancel out. And the reason for that is that with tangent inverse of the tangent of 2 radians, if I'm specifically talking about radians, we're going to say this does not cancel. And the reason is because I originally said my angle had to be between negative pi over 2 and pi over 2. And negative pi over 2 is the same thing as negative 1.57. And pi over 2 is the same thing as positive 1.57. So this 2 is greater than the 1.57, so it's outside of that fair area for canceling. The third one, the sine inverse of the sine of 7 pi over 4. Does this one cancel? And the answer is going to be no. It is not going to cancel. And the reason for that is the 7 pi over 4 is greater than negative pi over 2 or pi over 2. So let me plug that in really quickly. If I go to my radian mode, sine inverse of the sine of 7 pi divided by 4, I can see I get this negative 0.7853, and the sine of 7 pi divided by 4. Yeah, negative square root of 2 over 2. So there is no exact correlation between those two. So you can see when I do work it out, they don't perfectly cancel out. I end up with the negative 0.78. They are not identical. And if I were to make my original 7 pi over 4 into a decimal, you can see 7 pi over 4 is definitely not those negative 0.70 or 0.78 values. So this one does not cancel. I could make it cancel, though, if I found a coterminal angle that worked with, which the coterminal angle we could find would be pi over 4. If I were to convert this to sine inverse of the sine of negative pi over 4, then yes, they cancel. The last one, if I look at it just the way it's written, it will not cancel because 3 pi over 2 is larger than 0 to 2 pi. So this does not cancel. So in order for me to solve this one out, cosine inverse of the cosine of 3 pi over 2, I'll start with the inside. The cosine of 3 pi over 2 is going to be 0 degrees, and the cosine inverse of 0 degrees is 90 degrees, or pi over 2. So that's how I would simplify that one down.